Welcome to the next tutorial on current electricity. Starting from this tutorial, I will discuss the solution to the problems. First question. From the figure 1.1, okay, let me pull the figure 1.1, okay. We can see the three resistances which are 5 ohm, 10 ohm and 30 ohms, which are connected in parallel in a circuit which is having a 12 volt battery. We have to calculate the current through each resistor. We have to calculate the total current in the circuit, and we have to calculate the total resistance in the circuit. Okay, so let me first pull a okay, so basically we have to calculate the current through each resistor. Okay, now we know the potential difference is 12 volt. That means potential differences between point A and B is 12 volt. Between potential difference across point A and B is 12 volt. That means the potential difference across all the resistances are 12 volt. The reason being, these resistances are connected in parallel, so they all will have the same potential difference. Since the resistances are connected in parallel, they will have. Now from now onwards, for parallel I will write two vertical lines like that. So potential difference across each resistance, from now on, for resistance I will write in short RS. Potential difference across each resistance, which is RS, is also 12 volt, because they are all connected in parallel. Now I have to calculate what is the current flowing through each resistance. Okay, let me pull a new board, that will be easier. Okay, I have some little bit space left here. Okay, current through no, I don't think I can do that. No, let me pull a new board, that will be easier. No, now current through 5 ohm resistance, the first one, through 5 ohm resistance is, from the Ohm's law we know that I equal to V upon R. So I1, if I1 is the current flowing through 5 ohm, I1 equal to V upon R. V is 12 volt, resistance is 5, which is coming as 2.4 ampere. Current flowing through the next one, which is 10 ohm. Current flowing through 10 ohm, if that is I2, ohm resistance is I2 equal to V upon R. Potential difference is 12, resistance is 10, so 12 by 10, which is coming as 1.2 ampere. Okay, let me pull another board because I don't have any space left here. Now current through 30 ohm resistance is I3 equal to V upon R. which is 12 upon 30, that means 4 upon 10, because common factor is 3, 4 upon 10, which is 0.4 ampere. Now, I have to calculate what is the net current flow. That means before they branch out, what is the net current flow? Now, we know that when resistances are connected in parallel, if the sum of individual currents will be equal to the net current. So, total current we can find out in two ways. One, we can find out the net resistance, or let me do it in a different way. Total current is the sum of all the individual currents. So, remember this, in a parallel connection the current flow will be divided into individual resistances, but if we add all the individual currents, that will be equal to the net current. So, I equal to net current equal to I1 plus I2 plus I3. I1 is the current through 5, I2 is the current through 10, and I3 is the current through 30 ohm resistance. Now, current through I1 first 5 ohm, sorry, current through 5 ohm resistance is 2.4, current through 10 ohm is 1.2, and current through 30 ohm resistance is 0.4. You add all together, it comes to 4 ampere. So, this is the net current flow. So, another way to find out is find the net resistance and divide the voltage by resistance, but I showed in a different way. Now, third thing I need to find out, what is the net resistance. Now, total resistance is, now remember these resistances are connected in parallel. So, we have to apply the law of reciprocal. So, total resistance is 1 by R, if R is the total resistance, equal to 1 by 5 plus 1 by 10 plus 1 by 30, which is coming to be 10 upon 30, that is 1 upon 3. Therefore, total resistance will be 3 ohm. This is the total resistance. So, now we solved all parts of the problem. Now, we can find the total current in a different way also, even though it is not necessary because we already found out, but we can also find that we can also calculate total resistance, sorry, total current as I equal to, that is dividing the potential difference of the battery divided by total resistance. Potential difference of the battery was 12 volt and total resistance was 3 ohm, so equal to 4 ampere.